Okay, guys, let's get started. Sharing the stream. Let's first handle the PR from Rafael, and then let's start training fasttext. There's a bit more data work to be done on the non-HBS front, and then we can kick up the training run. Let me just turn on the live chat here, and let's see what, do we have any pull requests? Okay, I think this is the only one. Okay, let's see what Rafael has done. Partially closes, it'll pull request 11, analysis need to be added. Allows downloading lang pairs from LNAI NLLB dataset. I've stored the NLLB pairs released with the paper, and CC matrix pairs in a separate Python file to import these variables into the main script because these two are rather big and could impair code readability. Resulting tree structure. Let me just see the code. Wait, what exactly is this one? CC matrix pairs. Okay, these are just two dictionaries, two lists of tuples. Download the LNAI and NLLB data from the Hugging Face Hub. Specify directory and minimal. Launch a minimal test to see if everything is okay. Two lang pairs. Target directory. Okay, there's a couple of things we could change here. I just won't leave comments here. On a particular line, can I leave a comment? If minimal, then we go through and then call download. Otherwise, go through these and download and done. Huh. Yeah, the thing here is we don't support all of these languages. Wait. And then there is a load the data set. And then we go through the dataset translation and we write that and then we close it down. Okay. Let's go to the training, guys. Train LID. Okay, we were left at I ran the generate non-HBS train data, but I haven't yet refactored this code here. So let's do that now. Split this on the right. Let's compare them side by side. We go through the primary data root, join target lang, if it's in the supported codes. In that case, we create the path, we go through the files. If the file ends with the target lang, we create the file path, we open it, we read the lines, we add the length to counts, and we add to the data, we extend with the lines. That's how we collect the data. Okay. I wonder how this would look like in PathLab, honestly. I think it's time to just take some time to see how this is implemented in PathLab. Okay, just via the glob. But what's the equivalent of not all files in directory, but only the first level? I guess that's specified by the glob. Okay, let's not go there after all. So I would love to reuse some of this code because we have non-HBS and HBS functions. We go through the data, grab the number of lines. Let's call this data as well. Data. And now these two are going to be the same, I guess. Target count per lang. Passing the data, which should be a dictionary of string to a list of strings. Target. Okay, so we go through the data keys. We grab the number of lines. And then subsample. Will this fail if we have less number of lines than what we are requesting here? Probably. Okay. Exactly. And I want to do the same thing here. Step 3. Filtering. Filter data. Open it up, go through the data, grab the lines, construct the filters, go through the lines, convert it to a data line, filter, clean lines, update this, return data. I think we have the same logic here, exactly the same logic. That's why it's faithful to do the same thing twice. Exactly. Random subsample data. And then go through the lines. Again, random subsample. Process the lines and prepend the label. Can we just use the random subsample again? Okay, this is a bit more specific. I'll just call this all lines again. And now this becomes the same code. So let's just post process and add data, create the all lines variable. Go through the data, grab the lines. Subsample. Process the lines. Prepend the label. And return back all lines. That's it. Green path. Green path. That's much shorter now. Okay. Now that we have done that, let's run generate HBS. Or maybe instead of doing that, let's create another function called generate LID data. That one is going to generate the non-HBS and the HBS. HBS lines, non-HBS lines. Then we want to merge them and shuffle them. Merge and shuffle. And finally, we do this. HBS train. HBS LID train. And this just needs to return back the lines. And same here. Awesome. Looking much better now. And then we can train the model. Return the train path. Train set the model is gonna call the data. HBS train path. We input that here. We train the model. We save the model. Much better. Let me see whether anybody is asking any questions. Nope. Okay, here we have one more thing left. We are missing German data. We are missing German data. Let me convert these into to-dos. This like completely would not work. You would replace 999 with 999. Better to just remove it altogether. Word engrams, if I remember correctly, was set to 1. Word engram set to 1, yes. remove the special characters. This is like new line. I think most of this will be removed, as this is punctuation. I think we would remove this by doing, let me go to process lines, normalize for LID. Punctuation. Exactly, these two are removed. We remove new line. We remove new line by normalizing the white spaces. We already have this covered. That leaves us with this bar. Is the bar removed? I think it is. If you take a look at, again, the punctuation. It's not removed. It is. So that leaves us only with these two special characters, which I think I'm removing through remapping here. So yeah, this is mapped to quotation mark, and then we remove quotation mark. And should be same for this circle. Okay. Looking good. Model path. This should probably be inside here. Nope, we should just pass train path. Okay. Much cleaner now. Last step before we can pick up the run is how do we collect German data? Okay. Let me quickly address this. German. I think they didn't focus on German that much. We can just grab some of these WMT data sets. I think Europarl, English to German. WMT. Okay, this must be good quality. And German is fairly easy to... How can I download this? Don't we already have Europarl? Download. Does Opus have data for German? Deutsch, DE. This is probably Croatia, Germany, Austria. This should have just a ton of data. Yeah, that's what I thought. Let's see. a ton of these smaller data sets, number of sentences. So we need around 3 million. So like we can grab Wikipedia, Europarl, a couple of these here. Let's do that. So we luckily have Opus downloader already, so we can easily do this. I want some diversity of data, so because of that, from Bible, these ones look good. All the way to Wikipedia. I'd fetch these ones and then subsample. How can we do this? Download Opus. Download data from Opus. Corporal list. Let's just clean this. Almost done. Nice. Okay, now the next step is, where do we save stuff? Opus download. Let's save it to data, German data. Source language is going to be English. Target is going to be German. Corporal list all. I'm not sure what this does. Make directory. Enter. Download data. Get ignore corporal list. Allow list is whatever is the corpora list. So that's the corpora list. So instead of that, let's add German data as the corpora list. German datasets. And let us run this. Set the opus config. Kick this off. Get the list. Get the ignore. Should be empty for the target. Ignore list. Well, ignore list should be Can we convert this somehow into default dict? How can we do this? I want to lowercase all of these. Okay. This should now work. Okay. German is not supported. Because why? Could it be that we don't have German here? Lol. Interesting. Kick it off again. Nice. Okay, we're downloading German data. As easy as that, guys. As easy as that. Now that we have built the muscles around Opus and have the scripts, this is gonna be super easy. Let it just run. German data. Am Anfang schuf Gott Himmel und Erde, und die Erde war wüst und leer, und es war finster auf der Tiefe. Und der Geist Gottes schwebte auf dem Wasser. Und Gott sprach, es werde Licht, und es war Licht. Und Gott sah, dass das Licht gut war. Da schied Gott das Licht von der Finsternis. Die Gnade unseres Herrn Jesu Christi sei mit euch allen. Amen. So that's Bible. Okay, this is a bit lower quality. I'm gonna skim through this just to see roughly the quality that we get here. Let it download, and until then, let's go to train LID. Petar root German. This should be just Turkish. And we can just repeat the whole process for both of these. And that's how we handle German. And English is a bit of a special snowflake because we have some, yeah, we could have easily shoehorned all of this in the same pattern, just adding here another root path. But yeah, this is good as well. Okay, dataset path. Aha. This has to be root. These are non-English language codes. And guys, with this, we are ready. We can finally kick off the training. We'll have to pick the right parameters for the training. We can use Flores dev test to do that. Step into the source code of fasttext. Aha, there is one mistake I made that I just realized, and that's the adding of labels. We won't be adding labels. We just want to group them into HPS and non-HPS. So that means we can't use key Is HBS set to true? Is HBS set to false? And then here we'll have either HBS if this is true, otherwise we'll have non-HBS. And that's all. So now for HBS data we'll have the HBS label, otherwise we'll have the non-HBS label. That's it, that's all we need. Hey guys. What goals would you recommend for a PhD student with no industry experience that's currently looking for a job? That's a tough one, man. Depends on where you're, what was your PhD about? That's the first question. And then depends on how willing are you to work hard, how ambitious are you, or what's your preference. Like, there is a ton of questions you have to ask yourself. If you are in AI PhD, I will probably be going to OpenAI or some of the startups that are just popping up, like Mistral or some of those together. I'm sure they're willing to grab PhD students who are really good and hardworking, even if you don't have industry experience. You have to get it at one point, so might as well be them. As always, I should have added a TQDM for download Opus. Let's see, where are we with our German data? $18 so far. How many do we have? 49 through 81. That's like what? 33? I think these ones are smaller, so it should be faster. Okay, I'm already thinking about potential failure modes of this LID system. We're going to deploy it as soon as we train it and see whether it's successful at filtering out Turkish, German, and English. I'm starting with German, Turkish, and English just because I've seen those failure modes. If we're gonna make this iterative, so we're gonna run with this trained model and see whether we notice any other languages, and then I can post hoc add those to the non-HBS data mix. That's how I'm thinking about this. Let's wait for this to download, and then I'll be back. Time for a short break while this is downloading. Hey guys, catch you in a couple of minutes. Maybe even sooner. Let's just see how quick this is. Okay, guys, let's see what happened here. Why did it stop here? No. Hopefully that was... I didn't hit that breakpoint when I went to grab a break because kind of beats the purpose. Okay. Let's see what else we have to do. Fuzzy deduplication is one of the next things I need to debug. I think we're getting really close to training our first model. While we're waiting for this, let me go back here and understand why are we filtering out all of the data from these other data sets. There must be some mismatch in indexing that's causing us to grab. This is always going to be different than the current index. And so we're constantly removing each of the lines. Okay. Let's put a breakpoint here. Go to filter. Directions. Primary. Let's run. Okay, enter here. Okay, we have global offset and line numbers covered range. So we grab the this should work, but for some reason it's not. Put the breakpoint here. Assert that counts equals test. Almost done. Good German. Int object has no attribute append. This should have been a list. Fun. Okay, let's let that run. We should pass this test. If we don't, then there is something, either some local bug here or some deeper flaw. Come on. Okay. They're the same. Then why the heck we okay, we're skipping because we already have all of the files, but they are empty. So okay, I have to delete the non-fuzzy. Before fuzzy, all of these files need to be deleted. Move to trash. This is the reason I have to rerun, because total after fuzzy is always 0 for some reason for all of the datasets except for the first one, which is definitely a bug. How do we construct a line? Let me see again. Counter. We encode the line and then we do +1. This should work, guys. I think this is either penultimate or the last dataset that we'll be downloading for German. Okay, we'll just step through the whole code path of the fuzzy deduplication just to make sure that I'm not missing something obvious. Okay. Let's go to filter. So We are now somewhere in this for loop. I'll put a breakpoint here such that when we enter the second dataset, we can see. Okay. So now I think each one of them will always be different. Okay. That's already violating my assumption. What the heck? Let's see. Total after fuzzy is 0, even though we know it's not. Maybe this is a bug not in the processing, but instead in the total after fuzzy counter. Maybe we are literally, let me see. If line is none, then we continue, otherwise we go here. Let's see. Okay. Total after fuzzy 3 to 6. EU bookshop. Save it. Okay. Let's continue. Wait, why are we skipping this? Is it empty? GNOME? Let's check the GNOME output before fuzzy. There should be data here, 17,000 lines. I have no idea what's going on. Why is this empty? Oh my. This is not a bug in fuzzy, this is bug in. You're probably overriding in the first loop. We try and open this up. Wait. If the file has been processed, then we never enter here. Let's repeat the same process. I'll have to delete this. Go to train primary. Let's leave only a couple of data sets. Maybe like 3. Tatuiba, this one, and Wikimedia. Save this. I'm not sure why it's complaining. Aha, because, okay. Not smart enough to. Comment out all of those, and here as well. So we are left with Wikimedia, Tatuiba, and this one. Go to filtering. And kick it off. Okay, we have our data for German. Let's go to train LID. And let's kick off train and save model function. We can delete all of this. Let's go. Run. Sample larger than population. I think I've hit the bug that I was afraid that will happen. Okay, yeah. So whatever is the smaller. Now let me see. Let me think for a second. Yeah, we want a minimum between this one and number of lines. If number of lines is huge, we still just want to have 2 times this. But if it's super small, then it's going to be the limiting factor. Okay. Okay. Rerun. Meanwhile, let's see what's happening in the stopes. We are running and waiting until we hit the fuzzy filter. Okay, we are now filtering the data. Okay, both of those are running. We are blocked on both ends. Trying to debug fuzzy, trying to train fasttext. Okay, we just check the hyperparameters. Two epochs. Learning rate 0.8. 256. The minimum maximum character and gram length of 2 and 5 respectively. Let me think. Where do we want to evaluate our model? I guess on Turkish. Let's prepare the Flores for German, Turkish, for all of the languages that we need. Download Flores. English, Serbian, Cyrillic. English, Bosnian, Croatian, English, German, Turkish, and English, which is already included in all these. So okay. Run this. Although I think it's gonna fail because I didn't download the previous one. Yeah. Eval datasets. We need to delete all of this and then rerun. No. What happened here? Oh no. That was a bug. This should have been data. Let's save the checkpoints along the way so that we don't lose the progress. Save the checkpoints along the way. LID data. Get the lines, we randomly subsample and then immediately save. So I want to save it as a pickle or something. If it exists, then pass. Otherwise, or if it doesn't exist, then we save. Dump the pickle. Just a second. So if it exists, then we open and read. Otherwise, we run and then save. Caching mechanism there. If it exists, again, read. Otherwise, do this and save. And same here. If it exists, then open it up. Otherwise, do this and save. Okay, and this should be, this is the HPS. 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 HPS, and let's repeat the same process below. Non-HPS. 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 Okay. Kick off again. Oh. We need to join this with this. Okay. Should work now. Go back to Stopes. Let me open up the data. Before fuzzy. Same here. Nice. Okay, again a failure. Aha. Length factors. Okay, let's just move that one to LAB data. And again, let's rerun. So this should now work. Why is everything failing constantly? Counts. Counts is a dictionary mapping from strings to filtering counts. And let's make sure that's always the case. Okay, which means now we don't need to do this anymore. And let's see now whether we're gonna delete some of the data we just built. I think that was the issue in this. That was the bug. We're somehow deleting the data previously collected. Okay, the data should be intact. Okay. Okay, we saved one. None of the data was filtered out. This is not interesting because I picked data sets that don't have duplicates. I was that smart. I couldn't have known though. Wait, there must be some duplicate here. Now we're having different issue. Like, it doesn't seem like we are ever... It's always empty. Aha. I know what's the issue. We need to delete this. We need to also delete this, 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 this. Okay, back where we started. The error I made was that I uncommented this whole piece of code. Which made it so that we had empty LSH index. That's why we were always getting empty and nothing is getting filtered out. We certainly have to find at least one duplicate, like, there is no doubt about that. Run. I expect to hit this line. Okay. Build domain hash. It's building up. Let's see how this other is progressing. We're saving the pickles. Filter data, subsample. Wait, why do we have... Okay. Here we are. Result 0. Index 0. Okay, we filtered out some. That's cool. That's promising. Now, let me put the breakpoint here again. Run. Nice. This already means that we have something saved up. Awesome, awesome, awesome. There is no bug. There is no bug. There was only some data being overridden. Save it up. And the last one. Let's see. With this, we have fuzzy running and we are almost ready to train the fasttext, which means we'll kick off the filtering job super soon. Zigzag. What was your time in DeepMind like, and what is Demis like in person? I didn't get to talk with Demis that much. I only spoke with him on one occasion, very briefly. He was almost never involved in the day-to-day, and you couldn't catch him around the office anytime. Hey, I have another question for you. Currently, which domain AI do you think we should focus on for our projects to increase our chances of getting good jobs? I don't know. There is a ton of things you could be doing. Anything around text to image or LLMs or like coding models, or if you want to go more practical, those are no-brainers. Embedding models as well, vector databases. There is a ton of things that you could do. Okay, let's see how we're progressing. Let's go. Almost done. I'm thinking I would love to understand better what is fuzzy marking as a duplicate and have a way to analyze the duplicates. Let me think. How can we... Maybe we can add like a debug flag. Same as with all of our other filters. And then pick up. Yeah, I think I have an idea. So length, for example, has this debug flag. Wait, where did I save that? Here's the debug. And we just saved to a certain file. So let's do the same thing for dedupe. Okay, we're done. And we are completely done. And now it's going to start the mine data processing. So total after fuzzy, 130,000. So fuzzy didn't filter out that much. Okay, this is great, guys. This is just great. Two things I want to do. Add debugging feature to fuzzy. And also think for a second, will mined data mess up anything or not? I don't think it will, because for mined we create a different, we create train primary. For mining, we should enter a different directory, so that's gonna be fine, but we might mess up stuff with min hashes. Let me see, how can we make sure? I think we might still have some issues here. Min hashes needs to be somehow distinguished between the primary portion and the mine portion of the data. Currently, we just grab the output directory and we make it, and then we start dumping stuff to it, and then later we read from it to build the LSH. Okay, but how do we create the fuzzy dedupe filter? Let's go back to filter.py. How do we build it? We build it by passing in the output directory. Okay, again, some bug there. Followed by min hashes direction. Okay, this is not enough. This is not enough. We actually have to have a group name here. Right? Because otherwise we would have issues. That was a bug. Okay, we fixed that. Primary. Let's rerun and make sure that we'll just skip to mine because primary is already processed. Okay, kick it off again. Aha, there is one more bug here. Make sure counts always has filtering counts. What happened here? Okay, same logic. Same issues here. Luckily, we have stored the intermediate points. Here we are. Let me make sure that we are not messing up the previous total. I'm gonna open this one up on the right hand side. Let's see the values. Convert this into string. Or a dictionary. Let's make sure these are the same numbers. 12, 5. Yes. Yes. 790. 600. 22921. Symbols 2714. Toxicity difference 35. Threshold. Pair dedupe 0. Target dedupe 0. Source dedupe 0. Pair fuzzy 12545. Okay, looking good. And let's go for the second iteration now with mined data. I'm expecting to create another directory here. Train mined, exactly. Okay, guys, I think this is good. Fuzzy is working. Here we need to add whatever is the minimum between this one and number of lines. If we have less number of lines, then that's what we take. Filtering data was super aggressive here, apparently. For Serbian Cyrillic. Would be cool to know how much data was filtered out here. Okay, rerun. Aha. Okay, one more step. If we have we don't have to do collection if we already have this. So basically we want to do this inside of here. And same for non-HPS data. This step, actually all of these steps, go inside of here. This goes here. Same as this. Okay. Kick off the run. Okay. Post-processing the data. Let's add the debugging feature for fuzzy. Hey guys, doing great. Slow and steady progress. Hopefully not that slow, but I don't know. I'm a single human working on this currently, so a bit slower than what it's gonna be in a couple of weeks or months. But at least I filmed everything, so once the project becomes big, that's gonna be a good social proof. Okay. I encourage you to check out the project and contribute while it's still in the early days. I'm actually looking for people with whom I'll be collaborating in the future, so this is the best place to do it. Okay, filter. Let's go to dedupe. Fuzzy. Laser. LID. Okay, let's just copy this. I need the same logic for dedupe. So I want to have debug. I want to have this. Like this. And then here in the query logic, when we are removing, I want to save those candidates and see them. Okay, let's see how we can do this. So we have candidate, which is I, and I want to pick up that line. So normalize line. Okay, so I want to do something like so this is the query, and then candidate pairs. So something like query and then go through the results. Let me think for a second. We want to do this only once. Okay, and we will. So as soon as the candidate is different than the current line, we enter, we remove the current line and return none. And along the way, I'm gonna write that query, go through the results, and again, if it's different than the current line, In that case, it's a candidate, and we thus write it down here. So now the only question is, how do I retrieve back? And this is going to be a bit tricky. How do I retrieve back the line that corresponds to this index? Because we only have the min hash, right? This is going to be a bit tricky. This is going to be tricky. We somehow have to store the information so we only have the LSH index currently stored as a member of this class. So that means we cannot retrieve the particular candidate lines. So in order to do that, I have to know which data set I need to grab and then which line inside of it. Okay, feasible. Let me just think what's the easiest way to do this. And maybe, just maybe, because we are either way doing this here with data sets, we can just build it up in the build LSH parallel. Number of lines, data set. Okay, I think I know how to do this easily. So if self-debug is enabled, we want to have a mapping index to data set. That basically tells you if index is I, then you have to look into that data set. Let me see how I can do that. What's the appropriate data structure for what I'm trying to accomplish? Let me think for a second. Global offset. I mean, because this is so short, yeah, we can just do something simple. We can literally do something super simple. Map the global offset to dataset. I think that's all we need. So for the first one, it's going to be 0 to this, and then we have some number of lines, and then we say this to this. Yeah, I think this is literally everything we need. So now that we have this, we go down below and say, okay, we have II. Go through the key in this one. Something like this, not completely. We actually want to go, if you're smaller, let me think for a second. So if this II is smaller than the key, if you're smaller than the key, just pass. Otherwise, you're equal to or bigger than the key. Which means this is the right data set. And now you need to read a line from it. Okay, this is crazy. I think I can reuse some of the classes I previously built for parallelization of LSH build process. Candidate line, set it to none. And here we'll somehow find the candidate line to do. Then we break, assert that candidate line has been found, and then just write it down. And that's it. At the end of the process, we just add one more new line or two more new lines. Let me think what makes more sense. New line, one more new line. Okay, two is fine, just to be visually easier to understand what's going on. So now the whole difficulty lies in doing this part. We have the data set, and we need to open it up and just read a single line from it. We find the offset index by basically doing this. And then now that we have that offset index, that tells us where inside of the data set we need to index to grab the line that we need. Now that we have that, I need to use the bytext chunker But for this guy to work, we have to provided the offset as well. Okay, this is hard. If we do it on the fly, it's gonna be hard. I mean, the dummy logic would be to just read from the start of the file, but they will be super slow. Some files are like millions of lines in length. That would be super suboptimal and would slow down the debugging significantly. So because of that, what I need to do instead let me open up this logic. Yeah, when you know the offset in bytes, everything is easy. But we don't know that. Unless we build some index that tells us for this line you have to go to this offset. And if we build that up once up in front, then that will significantly speed up the debugging later on. We can do that. I can't think of a better way to do this. So additionally, if we are in debug mode, we want to build that type of mapping that tells us for each of the data sets how lines are mapped to their bytes offset. Aha. I think we already have that logic though. Find offsets given line numbers. So let me think for a second here. We'll need a dedicated function. Find offsets for the number of chunks. And find offsets given the line numbers. We go through the line numbers. And we just save read line. Okay. Let's do something similar. So I'm just gonna copy this whole function. Call it build line number to byte offset map. Given a file, dictionary. So we open up that file. Okay, so what we do is the following. Line number to byte offset is a dictionary. And what we do is we do something like this. ftel equals counter. Counter starts at 0. Let's call it line counter. A line number. When do we stop here? Once we get to the end of the file. Okay, so we can do something like until while ftel is different than this. I think this is it. Probably don't need parentheses here, not Pythonic. Okay. So while the offset is different than the end of the file offset, let me maybe just grab this once. File size. Read the line, increment. Let's also assert that utils count lines too many values to unpack. What? Oh. Oh. Okay. Okay, the issue here is I haven't processed the German data. And we're currently probably dealing with German, yes. Okay, let's go back to that. Let me not switch the context right now, as this is a bit harder. Let me see whether anybody has any questions which are relevant to this. Aleksa, I recently discovered this amazing project you're building and wanted to share some thoughts. Is this model going to be able to infer punctuation symbols, or is that beyond the scope? I'm not sure what you mean by infer punctuation symbols. If you can clarify, I can reply. Because that's something you can do with just your regular software 1.0. You don't need machine learning. We're just trying to create currently multilingual machine translation systems which are going to be open source. Check out the OpenNLLB channel. That's where you'll find the pin posts and everything relevant you need to know about the project. Okay. Let's see. Let's see how this works. Count lines. Let's find the utils. Okay. This should work. Go back to dedupe, and we basically need to build this one. Pass in the file. This is from file chunker utils. Right here. And that is going to build us a map that then tells us, so we have index. So given a candidate index, we tell it, here's the data set. And now given the data set, we want to have offset. So we want to have data set to byte offset. So we do something like this. Data set equals this. Okay. And now that we have this, things are much easier because we have the data set. We grab the this should be called a bit differently. Data set to byte to line number byte map. A bit of a mouthful. Line number byte map. And now we grab the byte offset like this. And now we can open up the file and read the lines. Okay, slight issue again here. I forgot to consider both the source and the target. I'm afraid a bit about the memory consumption during this debugging, but like when debugging, I'll focus on one dataset at a time, so it's gonna work. So let's not worry about that right now. But the issue here is, this is for source. So dataset to line number. For source, we need the same thing for just for target. Dataset to line number byte map target. And this tells us This should be, by the way, source. I can't map using dataset. Dataset is an object. We can't use that to index into a dictionary unless we build a hash function for the dataset. Let me think. What do we want to do here? I'm not sure what data set, what's the data source. It's going to be the full path or what? Let's just test this. I'm going to put a breakpoint here. I'm going to set the debug to true. I'm going to go to filter file and I'm going to kick off the run, which should skip the above and just come here to this line. We should skip the first part because too few parameters. Yeah, this is wrong. This should be int to line number to int. Nice. Let's go. Okay, let's see what dataset is. So as you can see here, it has the whole name. So I think we should just store the name of the file. Although then what happens if we have the same file inside of the Streamlining? Okay, let's not worry about that right now. This is just for debugging purposes. So how can we reconstruct the path? Okay, I'm gonna do something like this. Grab the first dataset and dataset root path is gonna be this 0. Grab the source and basically just do OS path base name, or no, wait, how do we? What I'm trying to accomplish is extract not the base name but the base path. I think it's just we literally have it up there. This is how we do it. Okay, now that we have this, here we can index just using the file name. Okay, with this we can go down there, grab the data set. So we have the data set, which is the actual data set. This is the full object we store. That's fine. But now here we need to do this. Well, not quite. Let me think again. This has to be source. And this has to be target. So source, and this is for source, and do the same thing for target. And then we have the offset, and then we do source byte offset, and then we do target byte offset. Finally, we open the files, and we also open up the target. We seek the target. Okay, that's it. With some minor modifications, as you can see here, we have to normalize the line. Then we need to add not tab, but instead space. And finally, we need to repeat that here. Stripping is taken care of in the normalize function. And then we break. So this became a bit complicated, as you can tell. So let's extract this to a debug subroutine. Fuzzy debug subroutine. Self normalize line, result, and I. So we go through the results. Candidate line. Only if it's different than the I is when we do it. Okay, does this make sense? If it's different, then we build up the candidate line, assert it exists, and write it down. So how do we figure out the line? By going through the index to data set. This was a nice flex of various algorithms I learned over the past years. That's why algorithms and data structures are crucial. Aha, yes, it will be able to output anything that the particular target language has. So that's how these models work, right? They learn to model text. So unless we strip all of the punctuations from our data set, the model will be generating punctuations and everything else. Is there a nicer way to map index to data set? So we have a particular index. We're trying to find where it's located inside of this dictionary. This is fairly effective, I think. So while it's smaller, we pass, and then when it's bigger, then we just index to get the data set. And then we grab the maps. Let's test this. Grab the offset. This is the line offset index. This is the byte offset. Okay, let's try this out, guys. Run. Missing key. Aha. Aha, okay, these are data sets, so we can just index into them. We have to loop. So I can't do something like this. Instead, I have to grab the items fetch the next. And once I fetch the next, I need the source. Let's put the breakpoint here. Let's stop this. Run again. NLLB is short for no language left behind. Okay, let's see how this is gonna work. Can we do next on the items? Or did I mess it up? Yes, I did. I did mess it up. So item 0. How do we... We have to wrap it up into an iterator. If we do it like this, then it works. Let's try this. Wait. Okay. No, this is not good. This is not good. Wait. I hate when there is so many parentheses. So items, iterator, grab the next. So here we need source. And then after that we need, why are you complaining again? Iterator, next, source. This looks better. Tuple doesn't have source. Okay, let's see. Remove the source. Then we have to grab the first element. This should now work. And here it is. And we got ourselves a directory name. Okay. And each process has a dedicated direction. Okay. Put the breakpoint. Rerun. Okay. So global offset 0 to dataset. Let's see how this works. So we, oops, what happened? What happened again? No. F reference before assignment. What did I do? Okay, because I was stupid. I should have done this here. And then while tel is different than file size, well, it's smaller. Otherwise, we might have a infinite loop if something happens, I don't know. And then tel line number read. Okay, should be good now. Okay, let's go. Open this file. Grab its file size. And repeat this process until the end. Nice. 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 Awesome. Let's run this until we get to here. Cannot pickle. Text IO wrapper object. What? I'm not sure what happened here. And it's almost impossible to debug when it's happening in the sub-process. So I'll have to just step through the code and see what's up. Okay. I don't understand what has changed. Okay, let me just see quickly what's the change that was made. That's good. That's fine. Fine. Dedupe. Wait, why am I calling this current path? Aha. That's all good and fine. I don't see any issues here. I don't see any issues. No issues there. No issues there. I don't see any change that happened. That could mess us up. Weird. Awesome, thanks. Sounds good, man. Check out the getting started guide if you didn't see it already. It's in the, if you open up the README, and if you go to getting started, this is the best doc you should check out. Okay. Why do we have this issue? Can't pickle or whatnot. So it seems it's happening somewhere here. Let's put the breakpoint there. Rerun. Okay, here we are. What? Why is source offset not defined? Aha. Because that's something we get by looping through this. Okay, let's run. What's up? Let's try and get to the bottom of this. Looks like a Python problem, literally. Okay. Let's just try turning it off and on again. I'm opening up a wrong project. We need stops. Again, like I'm just a bit confused here because I didn't change anything that could cause that issue. Configs, filter, dedupe, file chunker. That's all. This definitely looks okay. File chunker. I don't see any issues with the code. And yet somehow when I run, it's failing. The moment we try to pickle. That's weird. We just have a single. Okay, let's just try and delete maybe some caching weirdness. Let's rerun this before I spend too much time debugging something that's not on my side. Okay, just run this. And while this is running, it's a good time to just make a short break. And then while this is running, I want to fix the German dataset for the LAD system. We need to bring it into the suitable format. You'll understand what I mean by that in a second. So let this run. Need to stretch my legs. Okay, guys. Let me see whether any... No worries. I don't know, guys, whether you can hear me. My camera died. I'm gonna stop the streaming and restart it with a new battery.